Hello and welcome. Here we are to solve grade 12 past papers of mathematics. Particularly the today's explanation will be focusing on mathematical reasoning or logic. The first question, it says, suppose the proposition P implies Q, P implies negation Q is false. Then which one of the following is true? First of all, just for starting, we need to be clear of the 5 logical connectives. The first one is, it's negation. The negation symbol is this one. So if you have a logical statement P, and the negation of P will be the outcome. So if P true, the negation will be false, obviously. If P false, the negation will be true. Don't forget, that is a rule of negation. The second one is conjunction or in end. Mostly we call it end. In case of end, if we have two logical connectives, two logical propositions, P and Q. Okay, the possibilities are both may be true, or true false, or false true, or false false. So what will be the result in case of P and Q? True and true is, it's true, and true false is false, false true is also false, and false is also false. So in case of conjunction or end case, there is only one possible truth, that is both true. Both has to be true, otherwise always true, false. It's false dominant. The only true outcome it has is if both of them are true, otherwise always, as you see, it is false. The third one, it is disjunction, or we call it OR, that is V, the symbol for V. Again, the same manner, let's take two logical statement P and Q. True true, true false, false true, and false false. These are the possible cases. Okay, for two logical statements, both may be true, or true false, or false true, and false false. What will be the outcome when we combine or when you connect them by OR, P or Q? True or true is true, and true or false is again true. False or true is still true, but false or false will be false. The only false case here, if it is both false. So conjunction and disjunction, they are opposite, and or it's always true, almost true dominant. The only case it will be false is both false, otherwise it's always true. So in case of logical connective, for example, if you have P or negation P, it's always true. How? Because P or negation P, when I say P may be true or false. If P true, the negation will be false. So one true there, so it will be true. If P false, the negation will be true. So still there will be one true. So one true is enough in case of or to be true, the whole statement. But in case of end, for example, if you have P and negation P, necessarily it will be false, because either of the two necessarily will be false. If P true, the negation will be false, so there will be one false exist. In case of end, say end is sensitive for false. If there is one false, it's totally false. So don't forget these things, please. Okay, let us recall the other logical connective. The fourth one, it is implication. Implication is, this is a symbol. Again, if you have P and Q, two logical statements, let's say true false, true true, or true false, false true, and false false. What will be the outcome when you combine them by P implies Q? In case of P implies Q, true implies true, it's true. True implies false is false, and false implies true is true, and false implies false also true. Here also everything is true, only one false case. This false case happens when the premise is true and the conclusion part is false. Don't forget that. So P implies true will be false. P implies Q. P implies Q will be false. The only case when the premise part, this is what we call premise, okay, the if part, this is only the conclusion part. If the premise is true and the conclusion part false, necessarily it will be false. Otherwise, every time it's true. If the premise is originally false, we don't care about the conclusion part. It's always true. So the only case, in case of implication, will be false if the premise is true and the conclusion part false. don't forget there is one rule here. P implies Q, it is the same as negation P or Q. This is also another rule. Okay, we can change this one in this form. There are many rules, like mostly commonly used. I'm trying to mention this one. Okay, the fifth one, let's clean it. The fifth logical connectives by implication. By implication, two arrows there will be. This is a symbol, both sides, the arrow. Implication is only just one arrow forward, but this one both forward and backward. So if we have again two logical proposition P and Q, let's say true false, false true, true true, and false false, let's say. This time if we connect them by implication, P by imply Q, so the true case will be when both true, the same, true true, you see. Otherwise it will be false. What did I do here? In case of by implication, both of the propositions should have the same logical truths. I mean logical true statement has to be the same. Look, true true will give you true, or false false will give you true. Okay, the one which is connected, if both true or if both false, the outcome will be true. Otherwise either of the two are like if they have different logical truths, then it will be false. For true false is false and false true is false. If they are not identical, it will be false. If they are the same truth value, they do have the same truth value, each component, then it's going to, don't forget this one also. Keeping this in your mind, and let's get back now to our questions. So when we come back to our statement this time, it says P implies negation Q is false. Look, P implies negation Q, this is already false given to you. That means to be false, it implies. So the premise must be true and the conclusion must be false. From this what we can conclude, P is true and negation Q false means Q is true. Because the whole is false given to us. That means P is true necessarily and negation Q necessarily has to be false, to be false. Because when we see the 5 logical connective, in case of implication, to be false, premise true and conclusion part false it must be. So this is already given to us. We cannot change anything. This is given. So P true, Q true also we got. So which one is true? Let's check. Now Q is true, means negation Q is false. False and whatever, it's false. So this one doesn't work. And again, let's get back B. When you come back B, Q is already true and this part is false. True implies false, this is whole false. And negation P also it's false because P is true here. So false or false is false again. This one also doesn't work. When you go to the next, P already true and negation Q it is false actually, it doesn't matter because it's or, the whole true. Okay, what about Q? Q is also true. How I know the whole true? Remember here, please, you need to be focused because this is logical statement. P is already true, we got it. So true or, this is or whatever it's true, because in case of or, if there is one true, that's enough to be true, the whole. So the whole thing, this one is true. Okay, if this one, the left hand side true and the right hand side we have to check. What is Q? Q is already true, we said it. We got it already here, Q is true. So true by imply true is true. So the answer will be C. Which one is true? It says the given condition is P implies negation Q. This is false. So from that we have got the truth values of each component P and Q, and then using that we are trying to check. If you try to check the D, it says P and Q. P and Q, each of them are true. So this is true. By implies, and negation Q it's necessarily false because Q is already true. So they are not the same truth value. So it will be false. So the answer will be C. Let's go to the next one. When you go to the next, suppose E of X is equal to X is even. Remember, E of X means it's a statement X is even. Okay. What about P of X? P of X means it's a statement x is prime. X is prime. Okay, the third one, d of x, it represents x is divisible by 2. X is divisible by 2. Okay, let us see now each of the logical statement, connective. It says which one of the following has truth value false? Which one is false? Under the set of natural number. Remember, we are talking about x, the set of natural number. Now, there exists x, e of x and p of x, means there is a number which is, e of x means even and p of x means prime. There is a number which is even at the same time prime. Yes, that number is 2. 2 is even number, at the same time it's prime. So there exists. Can we find a number or a natural number which is even at the same time prime? Yes, that is number 2. So this is true. B, for all x, e of x implies d of x, means for every x, if x is even, e of x means even number, implies d of x. If x is even, then it's divisible by 2. Yes, all even numbers are divisible by 2. Still, this is also true. Like by connecting, read it. For all x, it says, for all x means for every x, for every natural number x. If x is even, then this means implies means if then. If x is even, then it is divisible by 2. That's correct. When you go to C, there exists x, there is a natural number x. It is even, e of x and negation d of x. If it is even at the same time, not divisible by 2. Okay, this is that there is a number or there is a natural number which is even but not divisible by 2. Wrong. All even natural number necessarily has to be divisible by 2. So there is no even number or there is no even natural number which is not divisible by 2. Or even natural numbers are divisible by 2. So the answer will be C. The next one, it says if x and y are non-negative integers. Non-negative integers means starting from 0. 0 is non-negative. Which one of the following is true? For all x, for every x here, any x you can substitute. Y is greater than, there is y. For all x, for any x, we can take any x in place of x, we can take any number. For any x, we can find y, which is greater than that. Yes, take any number x, square it and subtract 1. Can you find another positive integer number? Like there exists y, means can we find one y which is greater than that? Yes, that is true, because it says for all x there exists y. You can take x, for example, x take 100, square it. 100 square, 4 zeros it will contain 10,000, then minus 1 it will be 9,999. No, 9,999. Now once, if we know from 10,000 minus 1, we said already 9,999. From this number, can you find any other positive integer which is greater than that? Yes, because for all x, you can take any number x in place of x, you can take any number, square it and subtract 1. So that, can you find y which is greater than the result? Yes, we can find. When you go to B, there is x. For every y it works. That means there is x for every y. Substitute one number x here, just fix the x, and then can you find for every y that statement become true? For example, take a number 0 in place of x. Let's say x is equal to 0. If you substitute 0 here, y is greater than 0 square minus 1. Y is greater than negative 1. 0 square means 0. Y is greater than negative 1. For every y, we fix already the x value, because it says there exists x. Yes, that x is like we take 0. There is one number x which is 0. If we insert in place of x, it works for all y. That is true. For every y, for any y. Okay, because y is non-negative positive, non-negative integers, means including 0. Whatever the y here, okay, any non-negative integers are greater than negative 1, that is still true. When you go to C, there exists y for all x. There exists y for all x. Y is less than or equal to. So when we are talking about there exists y, means we can fix like one number y. Let's say 0. 0 is less than or equal to x square minus 1. For all y, no, for all x, for all x, there exists y. Y is less than or equal to, means the minimum or the least value of y that we can take this time is just 0. which that number is always less than or equal to the outcome of the right side. Okay, let us check. But we can take any number of x in place of x. We can take any number. What if we substitute 0? 0 is less than or equal to 0 square minus 1, because x is free now. X can be taken in number. So 0 is less than or equal to negative 1. 0, it's his fault, impossible. So there is y, there is a number y. That number, the minimum y is 0, we can take, because y is less than or equal to, it says. There is a y which is less than or equal to any, okay, square of x minus 1. Okay, the minimum of y is 0 we took. Then x is free, we said. So is there a possibility like always to be true? No, because when you take x, because x is free, when you take for x also 0, 0 square minus 1 become negative 1. So 0 is less than or equal to negative 1, that's impossible. So the answer will be necessarily C. This kind of logical connectives are somehow challenging because it needs interpretation. Let's go to the next one. Okay, the next statement, again it says, consider the following argument for production is high if rain continues, and rain doesn't continue, therefore either production low or rain continues, it says. First of all, let's identify, here are the let part. Let P, production low. This is statement P. And Q, rain continues. So that this is logical statement. Either valid or invalid, that's the argument. Let's see it. Production is high, means the opposite. Production is low is P. So negation P if rain continues. If rain continues means negation Q or P. This is one of the premise. Rain doesn't continue. That means negation Q. This is another premise. Therefore means the conclusion part. The conclusion part. Therefore either production low or rain continues. Either production low means P or Q. Now our objective is to check whether this logical argument is valid or not, considering the premises are true. Always premises are true. This is true. Negation P true means negation Q, it is true means this is also true. Now if negation Q is true, the whole statement is true, because it's premise. The whole thing here is true necessarily, because it's premise. But negation Q already we know it is true. What about P? Do we know it is true or false? By the way, this is false already, because if negation Q is true as a premise, so Q will be false. So now we don't know about P. The whole to be true, if negation Q is already true, we don't know about P. It can be true or false, doesn't matter, because it's or. One true is there. So we cannot conclude about P. So this logical statement is invalid. It's not valid. If you observe the table also, it's talking like that. So the invalid case happens because of the last row, as you see here. So the argument form is invalid due to row form. You can check the table also at the same time, but what is the main point here? The premises are one premise here and the other premise here. The conclusion part is after therefore. The conclusion part, we took it. So our objective is to check whether it is without any precondition, will it be true? By considering the premise as true, we checked. The premise true means one of the premise negation P. Negation Q is true, okay, we took it. If negation Q true, Q must be false. Now the whole to be true, already Q false, so P must be true. Do we know about the truth values of P? We couldn't find. It can be true or false. Because negation Q false means here we substituted already, this is true. So the whole to be true, P is free now because it's or. P can be true or false. We cannot conclude or we cannot deduce whether P is true or false. Therefore the whole become not clear, so that it's not valid anyways. We cannot conclude the conclusion part is always true. The next one. The next one also, for real number x and y, which one of the following statement is true? For all x, there is y. That means x squared plus y plus 1 is equal to 0. You can take for all x. You take any number x, square it, and add with 1. Okay, for all x means take any number x. Any number. You can take, for example, 10. Then square it. 10 square, 100. Then plus y plus 1. Will it give you 0? 10 square, 100. 100 plus 1 is 101. Sorry, 101. plus y. Can you find a number? Because for all x there is y. So we take, as an example, we take in place of y as, like, in place of x 10. We take x is equal to 10. We square it and we add 1. Can you find a number or a real number y which will be added with 101 and give you 0? True. That is the opposite of 101. Okay? The negative inverse of 101. Then the additive inverse of 101 is it's negative 101. So for all x, you can take any number x. If you take 0, 0 squared plus 1 is 1. 1 plus, can you find a number which will give you 0? 1 plus what number? Negative 1, true. So that for any values of x, we can find y, which will be added with the other sum and give you 0. That is true. So which one is true? It says the answer will be A. The next one, it says let P and Q be P, Q, and R be a proposition given to you. P implies R or negation Q. The whole is what? False. False means, in case of implies, remember, in case of implies, to be false, the premise must be true and the conclusion part must be false. That means from this, what can we understand? The P value is true. The truth value of P is true. And here it's true, I mean or. In case of or, to be false, both must be false. That means R must be false. Also negation Q must be false. That means Q is true. Okay, it's or here. So the whole false means each of them must be false. That means R is false and negation Q also it's false. That means the Q is true. Now let us check which one of the following is true. A, P is true and Q is false. P implies false is false. Doesn't work. And B, negation R. Negation R means it's true. And what about Q? Q is also true. True implies true, it is true. Yes, this one works. What about C? Negation P. Negation P means it's false. False implies Q. It is false by implies. Sorry, by implies, not implies. Q is again it is true. So false by imply true, it's false because it's not the same. In case of by implication, both must be the same. And the last one, D, Q by imply R. What is Q? Q is true. What about R? R is false by implication. They are not the same, it's false. So the answer will be B. The next one, it says consider the following argument. If he doesn't love her, she will not marry him. He loves her, therefore she will marry him. So there are P, Q, there are two statements here. P, he loves her, and Q, she will marry him. There are two statements here. Now let's write. Now P means he loves her. Okay, let's connect it. Which one of the following is correct representation? It says correct representation. So if he doesn't love her, that means negation P implies she will not marry him. That means negation Q. This is one of the premise. He loves her means P. That is another premise. Therefore, what's the conclusion? Therefore, she will marry him. That means we are trying to find the Q. Now, this is premise. These two are premise. And the conclusion part is Q. We are trying to check for Q. This is a representation. So, P true already. P true means the negation Q, the negation P is false here. Okay, if this is false, we don't know about negation P because the whole is true already, premise. The whole, this one, the whole is true. As a premise, always premise will be taken as true. This is one of the premise. So it is true. So, okay, if the whole true and negation P already, like the premise part is false already, we got it. Because P true means the negation of P is false. So in case of implication, in case of already the premise false means, okay, the conclusion part is free. So negation Q is free. It can be true or false. If negation Q is true, this is going to be false. If negation Q is false, it is going to be true. So we cannot deduce, we cannot conclude about Q now. So it's invalid. So the answer will be B. Negation P implies negation Q is represented, one of the premise, the other premise is P, okay? So it is invalid. The conclusion part is Q already, it's here, but it's invalid. The reason why it's invalid, because we cannot say Q is definitely, it's not true, we can't say that. So that the answer will be B. This kind of logical statement Okay, by the way, the lesson, the unit itself is mathematical reasoning. There is no calculation here. We need to reason out. Remember the logical connectives. Keep that in your mind and then try to see in all direction. The next question. Suppose the following statements are premises of argument. He was lazy or he did not like the classroom. If he was lazy, he couldn't pass the exam. So there are three logical statements here. P, he was lazy, we can say. And again, he did not like the classroom, we can take as Q. He didn't like the classroom. Okay, the last one, he could pass the exam, R. Okay, he passed the exam finally. Okay, now let's connect it. He was lazy or he didn't like the exam. That means he was lazy means P, or he did not like the classroom, or Q. This is one of the premise. If he was lazy, again, if he was lazy means P implies he couldn't pass the exam. He could pass, we said already, so negation of R. He couldn't, this one we can say he couldn't pass. As it is, we can take it. He couldn't pass the exam. P implies R. He passed the exam. He passed the exam means negation R. R is also another premise. Now what must be the conclusion? Which one of the following could be the conclusion that makes the argument valid? Remember, these are the premise already given. He was lazy or did not like the classroom means P or Q. Because the P is he was lazy and the Q is he did not like the classroom. This is one of the premise. We can take as true, because premise always will be taken as truth. Okay, let's change the color. This is true. And other premise, P implies Q, because he says if he was lazy, that means P implies he couldn't pass the exam. That means he couldn't pass the exam is represented by R. So P implies R. Again, at last, he passed the exam. He passed the exam means the negation of R, because R is he couldn't pass the exam. So this is also true. Take true, true. Premise always true. If negation R true, this must be false. If R false, the whole to be true, P must be false, because if P true, it implies it's going to be false, but as a premise it's true already. So P must be false. If P false, okay, the whole as a premise it's true already, we said it's or. In case of or, there must be at least one true to be true the whole. So P already false, we got it. We are connecting logically, and we are coming here. Now necessarily the Q value must be true to be the whole true. So the conclusion must be Q to be valid. So the Q is what already? He did not like the classroom. So the answer will be B. The question says which one of the following could be conclusion that makes the argument valid, to make it valid. To be valid, the conclusion must be Q, because we go step by step. First, negation R is true as a premise. That means R is false. From this, he goes back. And if R false, the whole already has a premise true. So in case of implication to be true, if the conclusion part here false, the premise has to be false necessarily. So P false, we got it. If P false, it's combined by or and the whole true. So necessarily Q must be true. So the conclusion has to be Q to be valid. The next one again, it says P or Q implies negation R or and R. This is given to us. It is true. The whole thing is true. The whole thing is true, given to us. Which one of the following is necessarily true? By the way, negation R and R, it's false. It's false. The reason? Because I told you in case of and is sensitive. If there is one false, that's enough. So negation R and R, when we are talking, either of the two is true and the other one necessarily false. So the whole thing is false. If the whole thing false here, this must be false, because the whole thing again here, it's true already given to us. So here it implies. In case of implies, the first part we call it premise, the second part we call it conclusion. The conclusion already false. If the conclusion false, the premise part is cannot be true to be the whole true. To be the whole true, if this is false, this must be false. False implies false will give you true. But if this true implies false will not give you true. So that now already P and P or Q, it is false. That means both must be false. P must be false and Q also must be false. Okay, here now let's check the choice, each of them. Which one of the following necessarily true? False or false? It's false. False implies whatever, it's always true. Because the whole thing is false, it becomes, because both of them are false. False and false or false is false. False implies what? Anything will give you true. So this is without any precondition, this will be true. This is necessarily true. What about B? Negation Q, that is true. True and R we don't know about R. Okay, we cannot conclude, we cannot necessarily say this is true. To be true, R must be true, but we don't know about R. If you go to C, negation P. Negation P means true. True by implies R. We don't know still about R. R might be true or false. But D, negation P says, negation P means true. True or R. R, we don't know about R, but the negation P is true. That's enough to be true, the whole, because it's all. So the answers are D and A. Both of them are possible answer. Next one, which one of the following is a valid logical argument? Valid. That means considering the premise as true. This is true. That means this is also true. If this is true, we don't care about P, whether it is true or false. We cannot conclude P as true, because the whole as a premise it's true. But we know it's Q true from here, from the other premise. So if Q is already true, P can be true or false, the whole premise will be true. So we cannot conclude about P. So this is not valid. When you go to the next, P implies Q is true, and P by imply Q also true. Both of them has to be true. I mean, both of them has to have the same logical truth. True or false. It's okay. We cannot conclude anything here about Q. We cannot conclude. When you go to the next one, negation P and Q are true. This is one premise, that is another premise. That means here this is true and P also true. P true and Q also true. Okay, if Q true, R must be what? True, to be the whole true. So we can conclude here. Again, once let me repeat here. C must be clearly shown here. It says, look, negation P and Q, one of the premise. Q implies R is the other premise. The conclusion part is R. From this one, this is premise, the whole true as a premise. This also as a premise, the whole true. Okay, the whole premise true means here each of them must be true. Q true and this also true, negation P. So Q true means the whole premise to be true, R cannot be false. The reason, because it implies. In case of implies, if the premise true, the conclusion has to be true, to be the whole true. Otherwise, Q true, R false means the whole become false. But it's as a premise, we took it as truth. It's true. Therefore, R must be true here. So the answer will be C. Which one is logical? Like valid, the valid one is C. The next one, we are asked the negation of for all x, and then P implies Q. In case of negation, for all x will be changed their existence. The universal quantifier will be changed to existential quantifier. This is universal, this one is existential when you distribute. Then negation of, we have to change this one into the other. P implies Q is the negation P or Q. Now by De Morgan's rule, we can distribute. So there exists X. Okay, the negative, when you distribute, negation will be P, the or will be changed to end, and it will be negation Q. So which will be the result here? That is D. Okay, for all X is changed into there exists in case of negation, and then the negation will be distributed for the logical propositions for each of them. P implies Q. P implies Q by itself is negation P or Q. So when you distribute, negation will be positive, and negative positive will be negative, but the or will be changed into end. this thing it need revision. There is no calculation here. It's more of logical statement. Okay. The next one. Suppose P represent he missed the tournament. He missed the tournament. What is P? Okay. Let's try to see by different colors. Again, Q represents he got gold medal. Okay. R represents he took a trip abroad. Then which one of the following symbolic representation represent the statement? If he takes a trip abroad and he doesn't miss the tournament, then you see the if part is 2. It's combined by and. What and what? If he takes a trip abroad, take the trip abroad is R. So R implies, not implies and, sorry. If he takes the trip abroad and he doesn't miss the tournament, the then part is after that. If he take the trip abroad and, so R and, he doesn't miss the tournament. He misses the tournament is already P, so he doesn't miss the tournament with negation P. Implies, because this whole is if, then he will get the gold medal. He got the gold medal is Q. So if you take out, so R and negation P implies Q, which is found in C. This is the way how to represent. If he take a trip abroad, and he doesn't miss the tournament, these together like if part. These are the if part. So R and negation P implies the then part is he will get the gold medal, that is the Q. The next one, okay, it says for arbitrary propositions P and Q, which one of the following is valid equivalence? So that this kind of question we need to be systematic. Look, A, P implies Q and Q implies P, but it's negation. It's not the converse. To make the converse, both must be negated and inverted. It's not inverted. Both are not negated. But B, first of all, B, let's expand it. P implies Q means negation P or Q, and there is negation outside, and P there. Let's do one by one. Then distribute the negative here. Negation will be P, and the or will be changed to and negation Q and P. Now both of them are and, so we can write in any order, doesn't matter. P and negation Q. I brought the P and the P together. P and P is P, because if P true will be true. If P false, both will be false, it will be false the result. But P and P is already P. P and negation Q will be final result. So the answer will be B, because which one? Okay, for arbitrary prepositions P and Q, which one of the following is valid? The valid one is the P, because the left hand side and the right side are equal. We are asked to check they are equivalent. This means equivalent. They are equivalent here. We prove step by step. We goes here, and we arrived P and negation Q, which is equal to the right side. And the next one, if each of the compound proposition P or Q and P implies Q and negation R are true, it means P or Q is true, and P implies Q also true, and negation R is also true. Which one of the following is true? It says. That means first of all, let's check from this is true, means here P implies R. We need to check it. This is R. Okay, this is true, means this one false. The whole also true here. The whole also true, given to us. Okay, if the whole to be true, if R false, this must be false. If this false, to be true the whole, Q must be true. So P false, Q true, and R it's false. Now which one of the following is true? P, is that true? No. P already false. Q, it is true, yes. Then the rest you can check. The answer must be B. here we are again. Okay, when you go to the next one, which one of the following is tautology? So P or Q implies R. So we can change this one and check. Negation P means negation P implies Q implies R. This one we can write like, remember, if we have A implies B, it is the same as negation A or B. Okay, implies can be changed into or, but the first one will be negated. So we have to negate here the first, because there is implies here, as you see. To change this implies, we need to change this one to negative. Negative of negative will be P. P or Q implies R. This one and this one are the same. They are the same. So if this true, true. If this false, false. So it's by imply. By imply means both must be the same truth value. So this is tautology. If you go to the next, P or the bracket Q implies negation Q means negation Q or negation P. Okay, so let's make it clean first. We are talking about B now. Q implies negation P. This means negation P or negation Q. And there is P or here. All of them are or. So we can remove the bracket. P or negation P or negation Q. P or negation P, you know, P or negation, in case of or, one of the two is necessarily true. So one true is enough. True or negation Q. True or negation Q is also true because it's or still. There is one true means everything become true. So it is tautology. Tautology means always true. This is also always true. When you go to C, it says P implies Q again. P implies Q, we can write it negation P or negation Q. I mean negation P or Q. The first also will be negated. Then or Q. Still, there is implies. To remove it, negation P or Q again or Q. Okay, first we remove the bracket implies, and again we go to the outside implies. So everything is or. So we can write it negation P or Q or Q. Negation P or negation P, it's just negation P. We can't know anything about it. Both are the same. Here we said one P or negation P true. Why? Because they are not the same. They are opposite. But if they are the same, we cannot say anything. As it is, it will go down. Or Q and Q also, it's Q. We cannot conclude this is always true. So the answer must be necessarily C. Because A, we got is always true. The left hand and the right hand side becomes the same, means it's by implication both true or false. B also we showed that always true. But C, we cannot show always it's true. We got negation P or Q finally. This one is simplified and gave us negation P or Q. So that we cannot say it is tautology. The next one, again, which of the following compound proposition is tautology? So Q or negation P. This means, by the way, Q or negation Q or negation Q. It is true. True implies what? We can't say about P here. If P false, the whole will be false. If P true, the whole will be true. So it's not always tautology. We cannot conclude about that. When you come back here, again, this is also true. Q or negation Q, it is true. Okay, the premise, whatever it is, if the conclusion false, it's always true. So this is tautology. The answer will be B. The next one is the truth values of a proposition P is false. P false, remember. Then which of the following compound proposition has the truth value true? P false means this is false. Enough to be false. The whole will be, because it's end. And again, P false means the premise we don't care about that, because it implies the whole will be no, this is true. P false means the premise will be true. True false is the whole will be false. Again here, P false or true, again negation. True or false is false, I mean true, and negation of true will be false. So still this is also false. And here P is already false. False implies whatever. Actually it is true here. False implies true will be true. So the answer will be D. So these are some of the questions that we were doing for today about mathematical reasoning or logic. Really it's very interesting. One of the outcome of learning mathematics is reasoning out. So keep on practicing or continue preparing videos this lesson or these questions are specifically on the unit mathematical reasoning. Thank you for watching. Share to your friends and subscribe.